Good afternoon, Ms. Sumi, and everyone gathered here. Today, our team is excited to delve into the transformative role of image recognition in insurance sector. Together, I'm June, joining with Fred, Richard, and Min. Together, we're going to delve into the essence of image recognition in insurance sector, its technical background, and its application, and we'll conclude with a discussing of future prospects. Before we start, let's kick things off with something interactive. Take a look at this image on the screen. This is a CT image of a patient who's suspected to have lung cancer. And can you spot out the tumor here? I'll give you 5 seconds, you can give it a try. Difficult, isn't it? The highlighted part here is actual tumor, and with some white, similar white spots, you might be confusing. And it is really challenging to pinpoint, especially for non-medical professionals like most of us here. Now, imagine scaling up this task to 20 images, or maybe 200, or maybe up to 2,000 images. And imagine how tiring it would be. Okay, so leaving it aside, let's move on to discuss about the pricing in health insurance. So, in order to price the insurance, we need the accurate examination of health condition, because health condition of an individual differs. And in order to have the examination of health condition, for example, of this lung tumor scenario, we need to determine the tumor size, and which could determine the stage of cancer, and also further expect the life expectancy. And together, all this information goes to the insurance company to calculate the risk loading, whether to increase the price or decrease the price. So this is how the process works. And you might wonder, the process is far more complex and labor intensive than it seems. And therefore, the application of image recognition could somehow help to manage the task. So what exactly is image recognition? In simple terms, image recognition enables machine to detect object features or other useful information from image or video. This process includes recognizing the pattern, color, shape, and texture. So, you might wonder, why image recognition is so significant? Why not rely on human? It is because machine processing is more accurate and efficient and more cost effective, and it could easily scale up or down, resulting in reduce of risk of human error and increase the productivity. And it could also help business save cost, and it could process for larger data set and with additional computing power. So let's get back to this lung tumor scenario. As a result, a physician might overlook the symptom by giving a tumor size maybe less than 1 centimeter, and ignoring the symptom of early cancer sign, and maybe expecting the wrong life expectancy to give a wrong risk loading, which can give result in loss in the health insurance business. However, the precise machine can calculate the exact risk loading by giving exact examination of this tumor. resulting in maybe increase in price or decrease in price or increase in this case. yeah, this example so far underscores the invaluable role of image recognition in insurance. And we're just scratching the surface here, and we'll dive deeper to cover the technical part with the technical process. And we give an example of image recognition in insurance sector by giving out some case studies. Maybe we can further discuss the challenges of it. And we conclude by giving a future prospect. As such, I'll pass the mic to Fred, who's going to cover the technical part here.
Thank you, Jim. Now, before talking about the core technology, I would like to ask a question first. Like, do you think that machine and human recognize the objects in the same way? It's quite confusing, right? Let's see some pictures. Like, for the pictures on the left, we can clearly see that this is a woman that's standing on the field. But when we look carefully, we cannot see that facial features. But however, for the second pictures on the right, we can clearly see its eyes, nose, and mouth. But there's a lot of people complaining that they cannot recognize this is a woman. So from this, we can know that people recognize objects from the whole to the part. However, for the machine, this process should be reversed. Let's take animals as an example. Like how different animals are recognized. You can see on the chart, there's a cat and dog, and a machine can recognize them clearly. So the machine starts from the character of the animals. The first is some low-level features, which includes the outline of the animals and also the edge of facials, for the eyes and nose. And then we go to the mid-level features, which is all of the eyes, ears, and tails and mouth, something like this, and also how they are sit, how they are stand there. And then for the final stage, we combine everything we get from the lower and mid-level, and it is pieced together into the whole through information obtained previously. But just knowing these does not seem that we have a good understanding about how the image recognition works. Because we still do not know how the image recognition system turns these fragments information into entire organism. Then this is a problem we have to solve next. First, let's see these pictures. We can see there's a bee on the flower, and we put this part, and we enlarge this part, and we can see there are different blocks on the pictures, and that is the pixels. So the pictures are made of the pixels, and the color of the pixel is determined by the numerical value, and that is how we turn an entire picture into data. And before we throw the images into the recognition system, there's still something we need to solve. First would be the grayscale transformation. In this part, we will lower the image, the image quality. You may ask why. Like for us humans, it is we prefer high quality pictures instead of the lower ones. But for machines, they are just opposite. Like by lower qualities, we can have faster process speed, and we can process more data in the same time. And for the second, and then we'll go to the data arguments. We'll go into the data argument. As we know, we all have limited amount of data no matter for the internet or other place. But there exists infinite kind of situations in the real life. So it's actually necessary to use data argumentation to make sure that the system can detect all kinds of situations, which should be including grayscale, flipped, rotate, shift, and cropped and brighten. And then we'll go to the third stage, which is feature extraction. And by using all kinds of filters, we can make the model easy to extract the similar features. Like in these pictures, it will be the oral object, and known as the steering, and the rectangular object, which is known as the phone. And we can see that the feature of this picture will be drivers that's distracted by phone. And now we can throw the data into the convolutional neural network. So the convolutional neural network includes several layers, which is convolutionary layer, activation layer, pooling layer, and the fully connected layer. It sounds too academic. Like let us make it more simpler. So we can see this is a picture that I made with Excel. So it contains a number 7, which is made up by number 1, and block is filled by white color, and the surrounding is surrounded by black blocks. And we can see clearly that this picture only have 2 features, which are known as the vertical feature and horizontal features. So this is the convolutionary kernel of this image. And after we do several calculations and other process, we can get a 18 times 1 data set, and this is known as the feature of number 7 in the data. And all kinds of features have a similar data, and that is how the machines detect all kinds of features, which includes also human beings and other animals. This part may sound so academic, so let's talk about something daily. I will hand this part to Richard.
Thank you, Fred, for explaining the working principle of image recognition. Now let's see how we can apply this technique into insurance. We will mainly focus on 3 applications in this section. The first one is driver behavior assessment. They can classify the training data into normal and dangerous behaviors. After the model is trained, it can monitor and record the driver's performance. So, if dangerous behavior is detected, real-time warnings such as voice notification can be given to reduce the risk. And then, besides, this assessment could also be a factor considered as a factor in insurance pricing. For example, if a driver is labeled as unsafe, like they use mobile phone frequently, they may need to pay higher insurance fees. The second one is image recognition in damage claim process and fraud detection. In traditional claim process, there are 6 steps. First is submit the claims, followed by original receipts showing the repair cost. And then all the data is manually transferred into the computer for analysis and reports. And then experienced employee will assess the claim. And then the claim approval decision is made, leading to insurance payment. Well, the process is structured and logic, but it's time-consuming and involve many labor force. Let's see how image recognition can improve this. The new process, there's a similarity in first and the last steps. In the second step, the image recognition will auto-check the image and make a cost estimation. Then a machine learning will guide the workflow and streamline the process. Here's an image showing demonstrate the process. The computer will recognize the damaged part for the car and then give suggestions for each component, such as either it needs replace, repair, or do not need to take action. Then an overall assessment is given, including the repair cost and actual cash value. The worker can then accept, reject the outcome, or make further adjustment. The system is impressive, but claim can be made repeatedly to deceive the system with identical damage. So to address this, a fraud detection system can be implemented. Well, the diagram looks complex, but the idea is simple, just like checking for plagiarism. Compare the similarities between a new piece of work and the database. In this system, the network is trained with identical car damage, but in different contexts. For example, the surroundings, lighting, and the capture angle of capture. And if fraud is detected, the system will reject this claim and ask for a new one. Otherwise, it will record this claim in the system and then exchange it to other parties like consumers, let's move to the third scenario, is roof damage assessment. Well, hailstorm is one of the most dangerous. Hailstorm cause many. Oh no. Hailstorm is one of the most causes for the roof damage in U.S. And to determine the condition of the room, usually they need to send the inspectors to the roof. And the inspector needs to climb on the roof and identify the damage individually. And this poses a risk of falling down from the roof. And if they are overweighted like me, they may even worsen the roof condition. Let's see how we can improve this. We may use a drone to capture the condition of the roof and then send it to the network. Then it can detect and locate the damaged part. Here's an example. The left image is a roof captured by drone, and the right one is a heat map. Each point in the heat map is mapped to the original picture after transferred into the network. And the color scale represents the probability of detecting damage. So if we compare the bounded box and the high probability region, we can see that this network can successfully identify the damages. So from our three examples, we can see there are many benefits of using image recognitions. For example, improve efficiency, like fast assessment, and also increase accuracy and reduce cost. Yeah. However, the system is not perfect. There's many challenges they met when you apply them. Let's me pass time to Mingyang to discuss this part.